You know, an expert is an expert. So I'm not sure I'm an expert in anything. Yeah, okay. I'm Gerald Pollack, and I'm a professor at the University of Washington in Seattle. I've been, for the past couple of decades or so, I've been studying water. And we discovered something interesting about water. Most people, almost everybody, knows that water has three phases: the solid, ice, liquid, and vapor. But we discovered a fourth phase of water, and this phase is an ordered phase of water. The molecules are organized, kind of like a crystal, and it's all over the place. This is the water that actually fills your body. So it's pretty important. If you want to understand how the body works, then you have to know about this fourth phase of water, which, by the way, we call fourth phase, or EZ. EZ stands for exclusion zone, because this liquid crystalline water tends to exclude almost everything. It's like ice. You know, when ice builds, it pushes out all of the particulate matter and contaminants and such, and so you get a pure crystal. This water is just the same. So as it grows, it excludes, and therefore someone said, you know, you should give it a name. So exclusion zone sounded good, and it's EZ to remember. So it works. Yeah, the structure, it turns out from the many experiments that we've done in the laboratory, based on the characteristics that we've deduced, the structure seems to be a honeycomb sheet, that is, hexagons. So if you think of the first layer is a sheet of little tiny hexagons, and the next layer is another sheet of hexagons, and another sheet, and another sheet, and they build upon one another. So you get a stack of these sheets of hexagons. That's not too different from the structure of ice. In the case of ice, the hexagons are all aligned with one another, and they're pushed apart. You know, ice is not so dense, it floats. They're pushed apart by protons, positively charged protons, that insinuate themselves within these layers. But in the case of EZ, or fourth phase water, there are no protons. The surfaces are very close to one another. It's a dense structure, and the hexagons are actually shifted, slightly shifted, between different layers. So this is the structure of the fourth phase of water that we've discovered. Oh, nature loves hexagons. Carbon structure, for example, graphene, that was discovered only in the past decade. The structure is almost identical to what we're talking about, except it contains carbons instead of hydrogens and oxygens. But I guess nature loves hexagons because it's a structure that is so natural. You can build with it. You can stack layer upon layer. And you can attach to each hexagon, you can attach different atoms to it, and come up with a whole host of interesting and diverse structures. So it's no surprise that water uses hexagons just the way nature does in so many different compounds. One of the things that we found is in the laboratory is that when you want to freeze water, so the prevailing paradigm is that you take water, you put it in the freezer, it gets cold, and the molecules of water transition themselves into ice. We found that's not true. It's sort of almost true, but not true. We found that what really happens is, as you reduce the temperature, the water converts itself into the fourth phase of water, and the fourth phase, or EZ water, then converts to ice. So it's a two-stage process, and without going into details, there are a lot of anomalies associated with the formation of ice. Those anomalies turn into expected features when you take into account that it's actually the water transitioning to EZ, transitioning to ice. The anomalies vanish. And when you melt the ice, you start with ice and you go to easy water, and then you go to ordinary water. When you think about the formation of snowflakes, and the question always arises, well, how come snowflakes have a hexagonal feature to them? And it comes right out of the easy water, because the easy water has a hexagonal feature. And so what happens is that starting with easy, the easies build and you come up with a hexagonal structure. And the reason each snowflake is different from any other snowflake is that the building process should be very sensitive to the environment. So it may depend on the amount of positive and negative charges that are in the environment locally. So one flake might be different from another. But one of the critical factors is that easy water is negatively charged. See, ordinary water is neutral, but the easy water is negatively charged. We found this through experimentation. When you think of the snowflakes that are falling, a question is, well, how come one snowflake doesn't bump into the next snowflake? They don't do that. You can see them remaining separate from one another. And I think the reason is that the easy water itself is negatively charged. So any two snowflakes that are near one another, both having negative charges, will repel one another. And so they stay apart. And that's why the snowflakes seem to come down rather uniformly. At least that's what comes out, hypothesis from what we've learned about easy water. It's a difficult question to answer because water is everywhere. Water is in the sea. Water is in the springs that come from the earth. Water is in the clouds, in the sky, and we're filled with water. So everybody knows that we're roughly 2/3 water. But something that a lot of people don't know is if you take that 2/3 and you convert, that's 2/3 by volume. And if you take that 2/3 and convert it into the fraction of molecules in our body that are water molecules, in other words, you take all the molecules in your body and you line them up and you count, 1, 2, 3, 4. It turns out that more than 99 out of every 100 molecules in your body are water molecules. And it makes sense because water molecules are small, and it takes a lot of water molecules to make up that 2/3 volume. So when you get to significance and importance, I begin to deflect my interest toward biology, because I think that's where it's making right now the biggest impact. Most biologists think of water as the background carrier of the more important molecules of life, like proteins and nucleic acids, DNA and RNA. And very few people think that water itself plays a critical role in our being. And if you open a cell biology book and you look in the index under the word water, despite the fact that 99 out of 100 molecules in our body are water molecules, you have a hard time finding the word water. It's there, and maybe there are 1 or 2 pages devoted to water, but it's almost considered to be almost irrelevant to the function of the body, except we have to keep hydrated. Well, nothing is further from the truth. Water plays an absolutely central role in everything that happens in our body. And that was the message of my 2001 book, which is called Cells, Gels, and the Engines of Life. It's a controversial book because it takes on some sacred notions, and scientists, like others, don't like to have their toes stepped on. It's human nature. And then the book that I wrote more recently, The Fourth Phase of Water, talks about in much more detail about the nature of the fourth phase of water and the applications throughout science and technology. And getting to answer your simple question, where's the impact? I'm sorry about going round robin to get there. And I think it's in the body and health. I think that water, we have evidence now that not only that water is central to all biological processes, but because of that, having adequate water is absolutely critical for health. And by adequate water, I'm talking about having an adequate amount of fourth phase water. This is the water that fills our cells. And without this water, your cells won't function. And if you have a full complement of easy water, then good chance your cells are functioning properly. But if you're missing some, if you're deficient, which some people would call dehydration, if you don't have enough, your cells are not functioning properly, and you need to restore that water. And there are a half dozen different ways that you can restore it pretty easily. We're studying exactly that now. And some of the ways are without going into great detail, of course, you need to drink a lot of water because the raw material for building easy water is water. So you need to do it. But there are other ways, and one of them, I just want to mention one because you don't want to listen to this long list. But one of them is, there are a lot of herbs and such that substances that have been known for millennia, starting with Ayurvedic times, that are known to be good for health, promoting health throughout your body. One example is turmeric. Another one is tulsi from basil, coconut water, coconut oil. We tested these substances and in the laboratory, and we found that so far, every one of them that has been designated as good for health builds easy water. So if you take turmeric, you're building your easy water, and that's the reason we think, at least one of the reasons why it promotes good health throughout your body, because water is throughout your body. So if someone asks, one of the things that I would comment is that it's possible that, we look for wonder drugs. The wonder drug of the 21st century, it could be water, as simple as that.